All right, I want to do the last problem in this practice test. So we have a projectile launched at 35 meters per second at an angle of 50 degrees. And this is actually a vector, so let's be clear. The projectile flies up into the air, reaches a maximum height, and lands. So it's launched at this angle of theta equal to 50 degrees, and the initial velocity is 35 meters per second. Actually, that's the speed, technically. And now what we're going to do is, this is a vector, so we're going to split it into its vector components, just as we've done before. So in this case, that's going to be 30 times the cosine of 50, or 35 times the cosine of 50, and that's going to give us 22.5 meters per second. And for uy, we're going to do something similar. So we're going to take this 35, and we'll take the sine of 50, multiply those two things together, and then we'll get 26.8 meters per second. All right, now we're done with the vector part. And this problem becomes our standard two-dimensional kinematics problem. So let's be clear. X naught is always 0. X is the horizontal range that it covers going from here to here, so that's x. We don't know what it is. Ux is the initial horizontal velocity that never changes because we don't have acceleration, and we really don't know the time that it's in the air for. S, also an unknown, that's the height that it gets up to. Uy is the vertical speed, and so we're going to end up getting here 26.8 meters per second, uy, because that's what we got from the vector component. Now vy, that's the v at the top, and that equals 0. And we're going to be using that for our calculation. And then a, the acceleration, that's going to be 10 meters per second squared because that's gravity, and the time is unknown. So for part A, we want the maximum height reached. Now we don't have the time, so we're going to use the following equation, vy squared equals uy squared minus 2as. I am just taking the equation right here and applying it. So that 0 squared equals 26.8 squared minus 2 times 10 times s. And that's going to give us 718.4. E minus 20s equals 0. When we isolate s, that's going to give us 35.9 meters. Next, we're going to do part B. We're going to get the hang time. So I can use v equals at. Sorry. Let's be clear on what the formula is. I get it from here. So that's, for part B, vy equals negative at plus uy. Now vy at the top is 0, and that equals negative 10 times t plus uy, which is 26.8. I'm going to skip some of the algebra. When you get the time, you're going to get 2.68, but that's just for the time up. That was the whole point of this problem. Part here was just to get the time going up. So the total time is going to be 2 times 2.68, and that's going to give us 5.36 seconds. Finally, for part C, we want the horizontal range it covers. So we're going to use x equals v naught equals uxt plus x naught. So that means the horizontal range is going to be 22.5. Where am I getting that speed from? Right here. And then we're going to times that by the total time because we're looking for the total horizontal distance, plus 0. And so that's going to end up giving us about, let's try that one more time. So 22.5 times 5.36 gives us about 121 meters worth of distance. So we have a total time of 5.36, a total height of 35.9 meters, and a horizontal range of 121 meters. So that is the last problem on this practice test. And we will take a look at the second practice test on the next set of videos.